video on the coordinate plane and coordinate geometry. And we're going to be talking about the coordinate grid, or the Cartesian grid, as it used to be called. It was created by a man named Rene Descartes. That's another extra credit question. So here it is, the grid. Right, and we should know, we'll just put some arrows there. Right, this is the y axis, and this is the x axis. And these are our quadrants. We have quadrant 1, quadrant 2, and it goes counterclockwise. Quadrant 3, and guess what the last one is? Exactly, quadrant 4. All right. So quad is a Latin word for 4. Right now we're in quarantine, and that comes from an Italian word meaning 40 days. Quarantina goes back to the Black Death, the Black Plague. 40 days of quarantine. Anyway, so here we have the Cartesian grid, the coordinate plane, the coordinate grid, whatever you want to name it. So let's say I put a dot right there. What is that point? So x comes first, then y. So if you plotted that, we would look at this here. That's 1, 2, 3, 4, 5, 6. So it's going to be 6 because the x comes first, and 0 because it's on the 0, right? On the y. So again, that's 6, 0. That is the points for that pair, for that point. And let's say we put another one here. What would that one be? How will we plot that one? Again, it's still 6. It's right on the 6 line. Then we have to go up. Here's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 6, 9. All right, and we can make a line. Let's make a line straight down. So if I want to know the distance between this point and this point, we'll just count. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 9. We'll say it's 9 units. And then let's say I had a point here, way over here. What would that point be? Put it out parentheses. What do you think? Again, x comes first. So that's 0, right? So 1, 2, 3, 4, 5. It's negative 5. Right? Negative 5 and 9. It's right on the 9. Negative 5, 9. So now what do you think the distance is from this point? Make a straight line there as best as we can. A little off. What is the distance between this point and that point? Just count the boxes. Doesn't matter where you count, right? Don't count the first one, right? When you're born, you're not 1 year old, right? You're 1 year old the next year. So you start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. Right? So we know the distance between here and the distance between there. And look, we can make a triangle. Now in later grades, we can get the distance between that point and that point using the distance formula, but that's for higher grades. So now we have a right triangle here, and you should know the area of a triangle already. We've done area of the triangle. What do you think the area of this triangle would be? Who remembers the formula? So I'll write it over here. Again, the formula for a triangle, the area, is going to be half the base times the height. Or it could be the base times the height divided by 2. Or it could be half the height times the base. So here, if we did 11 times 9, we get 99. We're going to get 99, and now we just divide it by 2, and that gives us the area of that triangle. What do you think the area is? Okay, and we'll just put it right in here. It's going to be 49.5 units, but units squared. 49.5 units squared. So we could get the area or the perimeter of certain polygons on the coordinate plane. Now another term we're going to talk about right up here, it's called vertex. The vertex. The vertex is the point where the two lines meet. See these two lines? Here's a vertex, and here's a vertex. This 3 vertex. And the plural for vertex is vertices. So we wouldn't say there's 3 vertex. We'd say there's 3 vertices. Vertex is the singular, and vertices is the plural. Vertices. So far, we know what a vertex is, where the 2 lines meet, the edge, right? And vertices is the plural. We know the number of quadrants. We know the name of this is called the coordinate plane or the Cartesian grid. Okay, and this is how you would spell René Descartes. That's René. It's French, right? So it's not René Descartes. It's René Descartes. Right? And put a little thing up there like that. René Descartes. Okay, so let's move on. Actually, I'm putting it, well, it should go over here, actually, instead of the other one. And actually, it's this way. Yeah, like that. There we go. All right, so let's do another one. Okay, so here I got 3 different polygons on the plane, on the grid. Here we have a rectangle. These are the points, right? So from this point to this point, it's 10 units, right? We'll count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And here we have 13. We don't care that it's in a negative zone. It's all about absolute value when you're doing this. So we'll count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have a rectangle that's 10 by 13. And the area will be 130 units squared. So here with the parallelogram, let's look at the parallelogram now. From here to here, this line, we have 1, 2, 3, 4, 5, 6, as we wrote down here. Now to get the area of a parallelogram, if you remember, we need the height. So that's why we did this dotted line, and we got the height, it was 9. So 9 times 6 will give us 54 units squared. Again, with the parallelogram, we don't care about this side, only for perimeter. Now you should look over the video to see these points I made. You should be familiar with plotting these points. So let's look at this shape. We have a triangle and we have a square. We can see the square has 5 by 5, which will make it 25 units. And then here we have the triangle. We have the base of 5. We have a height of 5. So it'll be 25 divided by 2. Triangle is always divided by 2. And we get a total of 37.5 units squared. Okay, so what we did here is we put polygons on the plane and we found the area. Great job.